welcome. In this lecture, we're going to talk about function compositions, which is something that you've likely seen before, but that you were actually never quite as comfortable with as you wanted to be, or you'll discover over time you're not as comfortable with it as it would help you to be. So I usually feel it's actually worth it, even at an advanced level, to go through this. So let's do that. So our setup is going to be, suppose that we're in a setup where we have that. So we have these functions. We have f from s to t. And we have that g goes from, I don't actually have it. Oh, well, we're going to go from t to, we have another one, we have u. And g is just going to be like this. Okay, so these are our functions. So these are functions where we have, so these are functions where we're going to have that the domain of g is going to equal, right? So when I'm talking about the domain of g, I'm actually, right, this is this t, right, is going to equal the codomain of f. Okay, so here we go. So definition, function composition. Okay, so the composition of f and g, so the composition of, and then we have our f and g, right? And this is going to be denoted g and f. So this is the composition of f and g. Is the function so we have g composed, so it's written, so this is g composed with f. Okay, so this is going to be a function which is going to go, right, it's going to go from s to u. And it's going to be defined by, it's going to send x is going to go to, and then we're going to go g of f of x. Okay? So, i.e., g composed with f of x is going to equal g of f of x. Okay, so here's our picture. So we have s, and we have t, and we have u, and we have that, so we have that f is going to map like this, and then g is going to map like this. Okay, and if I had a little x sitting in here, right, that's going to get mapped over to, by f, this is going to get mapped over to f of x. right? This is in T, and then that's going to get mapped over to G of f of x. So this goes to G of f of x. Okay, and then we get to this, we get G composed, right? And then this whole thing is, and this is where you're going to ask me, so why are we doing it this way? And I'll show you in a moment. This order here looks so funny compared to that, right? So what we're doing is we first apply. So we first apply f. And then we apply G. Okay, so here is how, so people often get confused. In fact, I used to get confused a lot about this also, and so I have a lot of, I understand that this is confusing on a personal level. So why is it like G composed with F? Like it doesn't seem to go in the same order as that. Okay, so why do we write? Why do we write it in this order? Okay. And it has to do with the fact, right? So this is like my personal answer. This is I don't know exactly the history behind this, but I know why it makes sense to me actually. Which is that x is written on the right. Is written on the right, right? And so we get, and you first need to apply F and then G. And then we first need to apply F. And then G. Okay, so it's like, right, because it's, when you're writing G composed with f of x, it really is that you first do this part, right? So you can imagine you're applying things to x in the order of how close they are, right? Because this does actually work with, right? This notationally works with G of f of x. Right, the order here matches up with that, and this is, I don't know actually if this is historically why this is done in this way, but this is why it actually in practicality works better that way, at least for me. And I think it makes it easier to remember also when you're writing which order you want to write them in. Okay, so I hope that made some sense, and I will see you in the next lecture.